Welcome back to Morgan Dynamic Research. So far in this series we have introduced the tapestry of nodes, the flow of source, tick and scalar time, and the stack of configurations at each node. In this video we're going to talk about cost. We will define temporal drag, temporal configuration drag, and how 3FFM reads mass as accumulated temporal cost.
In 3FFM, motion and change are not free. Anytime a pattern moves or a node changes its active configuration, the universe has to spend ticks to make that happen. Those ticks are not just a clock. They act as a kind of currency that measures how hard it is for the substrate to carry out the change.
There are two main kinds of cost that matter here. The first is called temporal drag, or TD. The second is called temporal configuration drag, or TCD. Together, they tell you how much temporal work the universe must do to move or reconfigure a system.
Let us start with temporal drag. Imagine following a tagged DH a specific thread of source as it moves from node to node. Every motion of that DH must obey the three-step motion rule you saw in the canon: alignment, configuration, and relocation. Each of those steps can consume ticks. Temporal drag is the total number of ticks required to resolve that motion under the DH rules and bonding constraints.
In other words, TD measures how much temporal effect the universe has to spend to carry out a change in motion. It depends on how many DH have to update and how difficult those updates are to coordinate into one overall action. If many DH patterns must realign, bonds form or break, and the change ripples through a large neighborhood of nodes, the temporal drag is high. If only a small amount of DH need to adjust, and most of the surrounding pattern is already compatible, the temporal drag is lower.
Temporal configuration drag, or TCD, is related but distinct. TCD measures how many ticks it takes for a system's present configuration to settle into a compatible and stable pattern. When a node tests its stack, stepping through candidate layers until it finds one that matches the incoming source pattern, each step costs a tick. The total number of such steps is the temporal configuration drag associated with that reconfiguration at that node.
So TD is about the cost of motion. TCD is about the cost of getting the local configuration ready to support that motion or change. If the right configuration is already active at a node, TCD can be 0 for that event. If the node has to search down the stack to find a compatible layer, TCD grows.
At the substrate level, 3FFM defines mass as the sum of these two costs. Mass equals TD plus TCD. That is, mass is the total temporal resistance to changing motion and configuration. The more ticks the universe has to spend to move and restabilize a pattern, the more massive that pattern is in this model.
This has an important consequence. There is truly no free inertial motion in 3FFM. Every relocation of a DH from one node to a neighboring node incurs at least a minimal relocation cost, and often additional alignment and configuration costs on top. Even a straight line path through the tapestry is a sequence of paid-for steps. Continuing to move requires a continued expenditure of temporal cost.
That might sound very different from the usual picture where an object in motion stays in motion unless something stops it. Here, what looks like inertia at high levels emerges from a balance between TD, TCD, and the way the environment is prepared. For example, when a kind of matter passes through a region, the stack at those nodes can reorder so that similar matter is easier to host again. This creates a wake, a trail of nodes biased toward that motion, which lowers TCD for follow-on paths.
So in 3FFM, a system prefers to keep moving along paths where the temporal cost of change has already been paid. Changing direction or mode of motion generally means paying new TD and TCD, overcoming the established wake. This is what inertia looks like at the substrate. Resistance to change in motion or configuration because it costs extra ticks to rewrite the pattern.
To summarize, temporal drag counts the ticks required to carry out motion. Temporal configuration drag counts the ticks required to resolve and stabilize configuration. Mass is the combined temporal resistance, TD plus TCD, seen by a system as it tries to change its state.
In the next video, we will see how these temporal costs combined with the local update rules give you locality and a discrete light cone in the tapestry. Thank you for watching.